Good afternoon. I am Renu Sharma, Assistant Professor, EC Department. Today I am going to start with the next part of the continued part of the previous lecture, that is network layer delivery, forwarding and routing. So, in the previous lecture we have discussed about how the packets, when it is reached at a particular router, how these are to be forwarded. So, that is basically based on the routing tables which are maintained at every router. Then these are the contents of today's lecture, that is Unicast routing protocol, then autonomous system and then the distance vector routing table. So, these topic we are going to discuss in detail. So, first one is Unicast routing protocol. So, in this Unicast routing protocol, a routing table can be either a static or dynamic routing table. So, what do you mean by static and dynamic? Every router has their own routing table depending on the nodes which exist between the two intermediate hosts, like this is host A, this one is host B, and in this there is router 1 and router 2, means two routers are there which has to be followed. So, this path has to be followed. These are the two intermediate nodes which exist between this host A and host B. So, the routing table can be either static or dynamic. So, static or dynamic means either it will be fixed or it will going to change depending on the different intermediate nodes. Let us say there are 5 routers connected between host A and host B. So, every time it is not possible or it is not advisable to connect all the 5 routers if it is exist between a particular destination, particular path. So, it may be possible that 2 or 3 routers we can remove. So, that is the case for this routing table. So, routing table can be either static or dynamic, which means it is fixed or it will going to change depending on the network which has been connected. So, a static table is one with manual entries, basically means it will going to be data will be entered manually. Secondly, a dynamic table is one that is updated automatically when there is a change somewhere in the internet. A routing table is a combination of rules and procedures that lets routers in the internet inform each other of changes. So, basically in the routing table, if we are heading towards, if we are going to connect the two particular source and destination, then this it is act as a static table which consists of manual entries, means in case of this static table manual entries will be made. In case of this dynamic table, we have to update that particular table automatically when there is a change somewhere in the internet. So, that is automatic, and static the entries will be made manually. So, this is an autonomous system. If you can see that 4 different autonomous system means 4 different independent networks which are connected over here, and these will going to follow this path, like you can see with this dashed line, this path can be followed. So, this is the first autonomous system, this is the second autonomous system, this is the third one, this is the fourth one. So, these are the 4 different independent networks are connected, and these are connected through this router. So, this is the path that has to be followed. So, this is router 1, this is router 2nd, this is router 3rd, and this one is router 4. So, this is how the data will going to flow from this autonomous system to this system. So, this is the concept which has been used for this autonomous system. Now, next one is the routing protocols. So, there are 2 different types of routing protocols that are used over here, like first one is the intra-domain protocol, second one is the inter-domain protocol. So, these are the 2 domain protocols which are used over here. So, first one, in case of this intra-domain, there will be a distance vector that is denoted by RIP, and in case of this link state intra-domain is basically when the particular routing protocol which has been followed inside a network, it will not going to connect the 2 independent networks. So, that is the case for intra-domain. In case of inter-domain, it is based on the path vector, and that is denoted by this BGP. So, this is the distance vector routing tables. You can see over here that this is node A, node B, node C, D and E. So, basically 5 different computers or 5 different systems are going to form this particular network. These are the different paths that has to be followed, like this is going to follow this path 5, this is going to follow path 2, this is going to follow path 3 and this is going to follow path 4. So, these are the paths that has to be followed, which are going to connect the 5 different intermediate nodes, that is denoted by A, B, C, D and E. This is like to the cost next, this is to cost next. So, basically what kind of table we have to follow, these are dependent on the cost of the path that has to be considered. So, the main aim when we are connecting a network, when we are going to make a network, establish a network, then the first aim is to find a line of sight, and if there is no line of sight, there are intermediate nodes exist between the transmitter and receiver, then the main aim is to consider the minimum path length, the shorter path length we have to follow, because every path have their own cost. So, this is to the next cost, like if you consider over here, that is the A's table, this is A, then it will going to follow 0th path, because if I want to transfer the data to A, then it has to follow this one. When I want to transfer the data from A to B, then it has to follow 5. Then if I want to transfer the data from A to C, then it has to follow 2. So, these are the entries or these are the tables which are maintained at every node. Like you can see in this C's table, for following from C to A, 2 will be mentioned for following from B to C, it has to follow 4, sorry, C to B, it has to follow 4, because C is the transmitter in this case. If it is C's table, then C will be the transmitter, these are the receivers and these are the path lengths. So, this is how the data will be transferred over here. So, this is the distance vector routing table. Next one is initialization of the tables in distance vector routing. So, this is the case when there is an initialization table will be maintained, like this is to the to cost next, that is the A's table, this is the transmitter, because the A is the transmitter, these are the receivers and this is the cost. Then again if it is D's table, then D will be the transmitter, these are the receivers and this is the cost basically to the next hop if I want to make. Then this is to cost next, this is second one, third table, fourth table and fifth table. So, these are the 5 different tables which are maintained at every single node, when 5 if different nodes are connected are going to form a particular network. Then this is the case for updating in the distance vector routing. So, how the data will be updated, like you can see that this is the packet which has been received from C, C is the node. If this packet has been received, then it has to follow this one. So, A's modified table which has been shown over here. If you can see over here that this has been changed to C to D is same, B and A. So, this will going to append, means updating in the distance vector routing, how this particular updating will be made. Then this is the A's new table. If I am going to compare, this is A's old table. So, this is A table, old table, this is the new table and this is the A's modified table. So, you can compare and you can form these two. So, these two tables are compared together to form this A's new table. So, this is how the updating will be made in the routing table. Now, next one is a very important topic, that is the Dijkstra's algorithm that has to be considered if I am going to form a particular network. So, this is a very important algorithm. So, this is the flow chart that how the particular nodes will be updated or will be made in case of this type of algorithm. So, this is first one is start, set route to local node and move it to the tentative list. So, basically this consists of the information about how the routing tables will be updated, how the information will be updated in this case. So, this is set the routing route to local node and move it to the tentative list. So, up to this point the list is not fixed, it will going to update depending on the packet which has been received. Then the tentative list is empty, it has to check that whether it is empty or not. If it is yes, then it has to stop. If it is not, then among nodes in the tentative list, move the one with the shortest path to the permanent list. So, basically if I am going to repeat this again, if a particular network is formed between two hosts, that is the transmitter and receiver, then the shortest path has to be considered, which is written over here also. If the shortest path is found between the transmitter and receiver, then it has to be entered into the routing table list, which will make as a permanent list, and the data will be transferred to this point. Now, next one is add each unprocessed neighbor of the last moved node to the tentative list if not already there. Then if the neighbor is in the tentative list with the larger cumulative cost, then replace it with a new one basically. So, this is how the data will be maintained. So, we have to add the each one of the unprocessed neighbor of the last moved node to the tentative list, which means that every unprocessed neighbor or something, it has to be moved to the last moved list, than to the tentative list if it is not already there. So, whatever path we will follow in a particular network, that is the shortest path, that has the shortest path, it has to be entered into the particular list as a permanent entry, and if it is not, then it has to be removed, then replace it with the new one. Then it has to come back again to see the tentative list is empty or not. If it is yes, then we have to stop. So, this is the procedure that has to be followed in the such type of algorithm. So, this is the example of formation of shortest path tree, how we have to form the shortest path tree. Now, you can see that this is the topology which we have which we are going to follow. So, these are the 5 different nodes which are going to make up this particular network. These are the path cost which are already mentioned. So, you can see if I want to move from A to C, then the path cost will be 2. If I want to move from A to D, then this path cost will be considered, that is 3. If I move from this to this, then this one has to be considered. So, this is the different path cost. Now, this is set route to A and move A to tentative list. So, from here we are going to start. So, this route has to be set to A and move A to the tentative list. So, the tentative list which we are having, we have to move this route to this A. If we found a shortest path, because at this point we have to make a decision that which path is having the shortest length. If it is fixed, then we have to make it enter into the permanent list. Now, if you can see in the second step, move A to permanent list and add B, C, D to the tentative list. So, the root node is made entered to the list, that is permanent list. Then we have to make a decision that whether we have to move C, D or B. So, B, C, D we have to select the next hop, because we cannot directly reach E from A directly. So, this is entered in the tentative list. Now, the next one is move C to the permanent and add E to tentative list. So, from here we can make a decision that from A to B its cost is B, from A to C its cost is 2, from A to B D its cost is 3. So, this is the least cost. So, we have to consider this path. So, this is A to C. So, C is made to be entered into the permanent list and add E to the tentative list, because from here we can move to E only. So, this is how we have to make a different second move. Now, after this third step, we have to move D to the permanent list, because this is having the least cost. So, this is how we have to enter this one. So, till now A, C and D, this one and this one, these are entered into the permanent list. Now, next one, fifth move is move B to the permanent list, and the data is how it is been entered, like this one B has to be moved to the permanent list. And lastly, E has to be entered into the permanent list. So, this is how the particular table has been maintained. This is the Dijkstra's algorithm, where we can find out the shortest path in a tree. So, a particular diagram is given over is given to solve, and to you have to choose at every point that which is the shortest path, which is dependent on the information which has been mentioned over here, the numbers which are mentioned over here. So, one by one, when every node you reach, then it has been moved to the permanent list, otherwise it will remain in the tentative list, and you have to move up to the point when the tentative list is empty. Now, next one is routing table for node A. So, this is the routing table which has been made. This is node A, B, C, D and E. These are the different costs that are considered corresponding to different nodes, like from A to this one the cost is 0 for this one. From A to A, if you want to move, then the cost will be 0. From A to B, the cost will be 5, from A to C the cost will be 2, then this is the remaining one. So, this is the routing table for node A. So, likewise you can make routing table for different nodes also, like for B, for C, for D and E. So, different nodes will have their own routing tables. Now, next one is the areas in an autonomous system, like this is an autonomous system which is consisting of different areas, like this is the backbone area which is denoted by area 0, this is the second area that is denoted by area 1, this is the third area where that is denoted by area 2. Now, these are the networks which are connected through routers, like you can see that it in this in this particular area there are 3 different networks are there which are connected through this router. This area is having 4 different networks which are again connected through this router. This is the backbone area which is connected to this network, and this is the backbone router you can see over here, this is the backbone router, and it is going to follow the bus topology somehow. So, this is the different autonomous system, and then it is being followed to the other AS. So, the other access points you can going to combine, or you can going to connect. So, this is the areas in an autonomous system, area 1, 2 and area 0, that is acting as a backbone. Now, next one is type of links that has been connected, like if you are going to connect two hosts, that is one is acting as a source, other is acting as a receiver, then how you are going to connect. So, first one is the point to point connection that has been established between host A to host B, that is between the source and the destination. Second one is the transient one, transient link can be connected, can be established. Second one, third one is the stub, and fourth one is the virtual. So, virtual is basically point to point is very simple, there is no intermediate node exists between the host A and host B. In case of transient, it will going to change at every point, transient states are there, transient states means it will going to update depending on the different path it will going to follow. Then next one is the virtual networks which are connected over here. In case of this virtual networks, the data will be followed from one point to another, and the connection which has been established between the transmitter and receiver, virtual connection will be set up, like it will going to change after every single point of time. So, virtually network will be connected, it is not fixed for any network. So, that is the case for virtual. Now, fourth one is the stub. So, this is an this diagram is showing the point to point network, that how the data will be connected in point to point network, like this is the router 1, this is router another router is there, and this is a point to point network which has been connected. So, there is no intermediate host is there, two routers are connected directly. Now, next one is the transient link. In case of this one, this is a transient network, and this is a kind of bus topology which has been established over here. So, there are different nodes which are connected, like this is router A, this is router B, this is router C, D and E. So, these are the different routers which are connected to this Ethernet or the LAN wire which is following the bus topology. So, in case of this bus topology, these different nodes are connected over here, like first A, B, C, D and E. This is unrealistic representation. Why this is unrealistic? If you are going to compare the A with the B part, then you can see that this is directly connected to the backbone. There is no overlapping of the connections made in case of this transient network, whereas in this case, that is the unrealistic version, there is overlapping of the pulses which are made over here, like A, B, C, D and E. So, overlapping of the networks which are created over here. In case of this realistic representation, this is much more realistic, because there is a designated router is there in between these small routers, that is A, B, C, D and E. So, this is the designated router which is been presented over here. So, this is denoted by C1. So, this is transient network, this is unrealistic, and this is the realistic representation. So, these are the different 3 different types of transient link which are connected in a network. Next one, third one is the stub link. What is stub link? Is this is a stub network. Now, you can see that it consists of a single router which is connected to this backbone Ethernet. So, Ethernet is nothing, it is a kind of LAN only, which has been established in a very small area in an office. So, that is a case for stub network, which is exist between in a single small network only. Now, next one is the representation, how it will be represented. It is consisting of a designated router. To this designated router, there is a particular small router which is connected to this designated router. So, this is the representation of the designated router, and this is the representation of the stub network which has been connected over here. So, this is the stub one, this is the representation. So, once again I am going to summarize in this different parts. Fourth one is left, that is the virtual network. In case of this virtual connection which has been set up, it will going to change depending on the requirement, depending on the different path lengths. Like in case of this Dijkstra's algorithm, which I have shown in the previous example, that whichever path is shortest one, it will going to select. So, at some point of time, let us say between A and C, the cost will be 5, and in the second case the cost will be 2. So, the second case will be considered, means the cost to connect between 2 paths will going to change every time. So, that is a virtual connection, means a permanent connection is not set up between the different nodes, it will going to change after a particular point of time. So, that is the virtual connection which has been set up, that is the fourth case. So, if we can see that in all the 4 cases which I have discussed till this point, that is how the different routers or different systems are connected in a network. So, this is based on point to point link, this is based on transient one, stub response, or the virtual connection which has been set up. So, virtual connection is much more easy, or it because it every time it will going to change, it will going to append every time we can change depending on the path length cost. So, that is the situation over here. So, in this lecture we have discussed about different unicast protocol, then we have discussed about distance vector algorithm, that how the cost of a particular path will going to change the connection between the 2 hosts if we have to consider every time the shortest path. Then we have discussed a very important algorithm, that is the Dijkstra's algorithm. So, these are the references that you can consider for this lecture. Thank you.